Okay, folks, so my hope is that you worked through this question. You used the previous page as a guide. I think all the instructions are there. Everything's there for you. So give it a shot and then come see me if you have questions. I'd be happy to help you. But there's enough kind of, I give you extra hints in here what your answers should look like as you're working through. So give it your best shot. And let's go ahead and continue. So as you do in calculus, what we're going to do is I'm going to give you an equation. And then we're going to take the natural log of both sides. We're going to take the natural log of both sides of that expression and then apply properties of logarithms to eliminate powers, roots, multiplication, and division from the expression. So this is tough, but let's go ahead and work it together. So I'm going to take this expression here and I'm going to take the natural log of both sides of this expression. And this might be our very first time doing this, and that's why we're practicing it. So I'm going to take the natural log of each side of this expression. And on the left-hand side, there's not much to clean up, but on the right-hand side, I now get to use all of the properties of logarithms. Put that in a different color. So on the right-hand side, I get to use all of the properties of logarithms. The big picture is I see a quotient of expressions. So I'm going to write this as the natural log of the sine of x times the cosine of x minus the natural log of the tangent squared of x. That gives me the natural log of y is equal to, and then look what we have here. We now have a product inside this logarithm, and we've learned in the last video that we can break that up as a sum outside of the logarithms. In this expression here, it's a little bit hard to see, but just to recall that if we write tangent squared of x, another way to think of that is to write it as the tangent of x squared. And so in this case, the entire argument inside the logarithm is being raised to the second power, so we can bring that out. Okay. And we've completed our task. If you go look at this problem here, we were asked to apply the properties of logarithms to eliminate powers, roots, multiplication, and division from any of the arguments. What you don't know is why in calculus we're going to want to do this, but I'll just say for right now, it turns out a lot of our calculus steps that you do when you get to calculus will be easier if you've already broken up some massive expression down into smaller expressions. Now, you can't just start breaking up this massive large expression, although if you argue there's some ways to factor it or clean it up, there definitely are. But a move that we're learning for the first time is to take the natural log of both sides of the expression. Then when we do that, we get to use all of our properties of logarithms to clean that expression up. Okay. So let's have you all try that one. For number 10b. So pause the video and give that a shot. So folks, there's the result of that. Hopefully, though, you tried it on your own and struggled with it and got stuck before you looked at the answer. It's always better to take a shot at trying to answer a problem using earlier examples as a guide before just looking at the solution. But let's go ahead now and do this last one all together, and then I'll give you one more to do here. So I'm going to go ahead and take the natural log of both sides of this expression. And if you see ways to go faster, you're welcome to, but I just remind you that, as you're doing these things for the first time, it's better to build good habits with them. Oops, that should be 3 to the 5 halves times 4x minus 1 to the third. So I've taken the natural log of both sides of that expression. Now that actually makes my left-hand side to this equation just a little bit messier. It's now got a natural log where it was just a y, but it enables me to clean up this messy expression using properties of logarithms. The big picture is I've got the natural log of a quotient, so let's use that quotient difference property, where I'm going to write this as, in fact, as I go, I'm going to go ahead and simplify that root as x minus 3 to the 1/7 power times x plus 1 to the 4th power. And we're going to subtract from that the denominator, the natural log of the denominator, which is x minus 3 to the 5 halves times 4x minus 1 to the third power. And this is pretty long. This is pretty messy. Like we're seeing how we have to just work with larger expressions as we go further in math. That's okay. Let's give it a shot. Inside of this expression, I've got now a product that we can separate by addition. So we get the natural log of x minus 3 to the 1/7 power plus the natural log of x plus 1 to the 4th power. And then here again, we've got another product in here that we can separate with addition, but we've got to be careful. So I'm going to put minus, and I'm going to put a big old bracket there, minus the natural log of x minus 3 to the 5/2 inside of that natural log, plus the natural log of 4x minus 3 to the 3rd power. Boy, we're almost done with this. The last thing to do is to recognize that I can use my product multiple rule to bring each of these powers out. Sorry, I said product multiple. I meant to say power constant multiple rule to bring each of these powers outside of the logarithm. So I can write that as the 1/7 times the natural log of x minus 3 plus 4 times the natural log of x plus 1. And I'm going to go do two things here. I'm going to pull these powers out of their logarithms. I'm also going to distribute this minus sign through. So I get minus 5/2 times the natural log of x minus 3 minus 3 times the natural log of 4x minus 1. Now, folks, I've had people say to me, Charles, can we do anything with that 4x there? And the answer is no, because the whole argument isn't a product. That's just one of the terms inside of the argument. So there's nothing I can do there. But what we've now done is we've taken this very complicated product quotient expression and we've broken it up into a bunch of individual pieces. Now careful here, we had to take the natural log not just of one side, but of both sides of this equation. So I'd like you to try that in letter D, and there are some answers there for you. But this wraps up this overview of the properties of logarithms. Thanks for your patience, folks, and bye-bye.